Okay, welcome back, guys. We're going to continue with our material relating to cardiovascular system. So let's move on forward. Okay, let's see where we left off. In our last video, we were talking primarily about the diagram of the heart as far as like the anatomical structures and the path that blood takes. That was very, very important. Where we left off, we were talking about the coronary circulation. So we were discussing how the heart itself has its own circulatory system via these coronary arteries and these cardiac veins. That was really what we've emphasized. Okay, so let's continue moving forward. Let's talk a little bit about some cardiac pathology. So in the instance of rapid heartbeat, which is not always indicative of a problem, but in the instance of a rapid heartbeat, that could be due to inadequate amounts of blood, which is considered fibrillation, and we'll talk more about that in this video. But that can cause a condition known as angina pectoris. I would just make sure that we know that angina pectoris is the same thing as chest pain. So obviously that's more of a symptom than anything else, but that can lead to more serious cardiovascular concerns that we should keep in mind. Okay, moving on. So a little bit about the heart's conduction system. So what do we mean by the conduction system? We're referencing its electrical conduction. So how does it move electricity? Normally, we move electricity through the body via nerves, but as you can see here, the heart is one of the most unique organs because its muscle cells do not need nervous impulses. They will continue to contract in a regular, continuous way because they have their own conductive system. It's an intrinsic conductive system, as we see here. So that's pretty phenomenal. So let's see what we mean. Not everything here we need to dive too deep into, but really there's a couple things that we're going to focus more on. So I'm going to star it. So for instance, the SA node or the sinoatrial node, it's found in the right atrium, but we commonly refer to that as your pacemaker. That is literally the part of the heart that's a bundle of cells that is going to send out a signal, an electrical signal, and that signal is going to communicate with the rest of the heart to beat. It can speed it up, it can slow it down, but it's the pacemaker. It's going to continuously make it go, go, go. That's the idea. We also have a couple other structures here, like the AV node, for instance. So in regards to the AV node, it's going to be the junction of the right and left atria, the AV bundle, which is called the bundle of Hist, which you don't need to dive too deep into, these bundle branches, and then we also have Purkinje fibers. What makes Purkinje fibers so unique is that they are similar to nerves. They're very similar. They're like cousins of nervous tissue, but they're not exactly nervous tissue. So that's why I'm emphasizing that they're similar, but just not the same. Here we can see on this next slide what it looks like, right? We can see right here the sinoatrial node, the SA node. It's sending out these signals to activate numerous parts. It's activating the right atrium. It's activating the left atrium. It's activating also the AV node, which will then cause a domino effect activation in the Purkinje fibers, which is going to help communicate to contract the ventricles. So pretty cool information. Okay, EKG, also known as an ECG. It's more commonly referred to as EKG, despite cardio being spelled with a C. In Old English, it was spelled with a K, so that's kind of the reason why. But an EKG, first, if you break this word down into its parts, it's actually pretty easy to identify what's going on. So let's just use a couple different colors. So for instance, the suffix gram. The suffix gram is used to identify a imaging or a chart or a graph or a measurement, right? So there's a lot of different things that you can use, and there's a number of different grams that exist in the medical world because there's a lot of tests that can be done on patients to see if they're healthy or not. Cardio, on the other hand, cardio is going to be one that we should know, right? Because this is the unit we're learning all about this, but cardio is all about heart. So cardio is all about the heart. Simple as that. And then finally, electro. Electro is another one that a lot of us should know as well. Electro is going to be indicative of electricity. So if you combine those three things together, you get an electrocardiogram, which is a device or a measurement of the electrical activity in the heart. So that's very important, how it's measuring the electrical activity of the heart. There are three formations of an electrocardiogram we need to know: the P wave, the QRS complex, and the T wave. It's just the alphabet, right? You just start with P, QRS, T. Now, there's a way to summarize this that I think, in my opinion, makes it easier to learn. So I'm just going to move this up here for the time being. So for the P wave, you notice how it says an impulse across the atria? I think what's easier for that than that is just flat out saying it's the atria contracting. Okay. Then for the QRS complex, this is a really weird one as far as spread of impulse down the septum, around the ventricles, in the Purkinje fibers. That sounds really complicated, right? I can summarize that a little bit easier and just say, hey, it's the ventricles contracting. Okay. Finally, the T wave is going to be the end of the electrical activity in the ventricles. So how do we summarize that? We can summarize that as saying the ventricles. Let me erase that. We can summarize that as saying the ventricles relaxing. So the ventricles relaxing is going to be the T wave. So we have the P, QRS, and T formations, which is what we expect to see in a normal EKG. And we can actually see that right here. So now we can see what an EKG properly looks like, right? Now, in regards to that, honestly, just make sure you're comfortable knowing that this entire branch right here, so all of this, P, QRS, T, all of this, if you were to see one of these PQRST regions, that is simply a heartbeat. Because notice, it repeats, right? You're going to have P, QRST, P, QRST, P, QRST. It's normal. That's expected. In some circumstances, though, there are instances where problems can occur. So, for instance, in this case, ventricular fibrillation, we talked about that already. Fibrillation is when the heart is doesn't have enough blood flow. But when the ventricles don't have enough blood flow, you can see this like spazzing of the waves. And obviously that can be an issue. So just be aware, be able to identify where each region or each formation is found here. Actually, I meant to change this. So let's change this while on the fly. This should say heart conduction. There we go. Okay, some pathology of the heart. And this is also a typo there. All right, damage to AV node. So if the AV node gets damaged, it can lead to loss of control in the ventricles, leading to slower heartbeat. A slower heartbeat can lead to fibrillation, and we talked about fibrillation a couple times already, but fibrillation is lack of blood flow to the heart. Not good, right? There are two conditions here that we need to understand, tachycardia and bradycardia. Just make sure you remember the numbers. Tachycardia is more than 100 beats per minute, whereas bradycardia is less than 60 beats per minute. So obviously that sounds problematic, but here's the deal. Tachycardia actually happens quite often, especially exercising or if you're stressed. If you're exercising or if you're stressed out, your heart rate can climb above 100 pretty normally unless you're like an elite level Olympic athlete. Bradycardia, your heart rate goes less than 60 pretty normally too, especially when you're sleeping. When you're sleeping, it's pretty standard for your heart rate to start to dip. It's kind of like a roller coaster. It goes up and down, up and down. Shouldn't go that far up, shouldn't go that far down. That's kind of the idea. And finally, to conclude, we have a little bit left for today's video. We can talk about the cardiac cycle. This is honestly a really straightforward concept. The atria, the two receiving chambers on the heart, they're going to contract simultaneously. Whereas when the atria relax, the ventricles will then contract simultaneously. So basically, what I find fascinating is that the heart, yes, it's just one organ, but inside the heart, different parts are working at its own pace. So the way I like to think of it is imagine you're clenching your fist. Clenching your fist by itself, that's pretty easy, right? There's no difficulty there. But if you were to suddenly have to clench your fist only your index and your middle finger at once, and as you do that, you have to then lift your ring finger and your pinky finger, and then you have to do this constant like up and down. You'll notice I already messed up doing it. By just doing that, it's kind of like a mental gymnastics. That would be so taxing on your body, but your heart does this automatically. So I think that's pretty impressive. And then finally, the last thing to mention is this concept of systole and diastole. Systole is just going to be in reference to contraction, specifically ventricular contraction. And then diastole is going to be referencing relaxation. These two words, systole and diastole, are very important. You're going to see those two words pop up again, and especially in regards to blood pressure, which we'll talk more about at the end of this unit anyway. Finally, This is just showing us what we just talked about on the last slide, but in picture format. You can see the stages going on in this cardiac cycle. This is late dystole. So late dystole is basically blood filling the atria and flowing into the ventricles, which is what you see here. Then you see systole, which is when the ventricles squeeze to shoot the blood out of the heart. And then finally, you see diastole all over again, the atria being filled with blood. That is normal. This is the normal process that we expect in the heart. This consistent systole-diastole balance is what we're seeing. Okay, so thanks for tuning in, guys. That was a great video. Not too many left, probably 2 or 3. We'll see how it paces out. But I appreciate you guys tuning in. Have a great rest of your day.